The reactant has carboxylic acid treated with soda lime, NaOH, CaO, heat. It is a soda lime. We know that carboxylic acids in the presence of soda lime undergo decarboxylation. So we have to remove the CO2 and write down the corresponding carbon ion. Now here we know that whenever the cyclopropane is there, so ring opening also possible, ring closing also possible. So here ring opening possible in two ways. The first possibility is 5-membered ring and corresponding C minus. Next possibility is you can break the bond like this. Second possibility, so this is equal to 6-membered ring, double bond, C minus. We know that when compared to 5-membered ring, 6-membered ring is more stable. Therefore, it is a major intermediate. Now it will be acidified and finally it gives corresponding alkene. Now this alkene treated with O3 and H2O. So it is a ozone. It is a ozone molecule. Ozone molecule is electrophile. So alkene react with ozone. After that it undergo oxidation in the presence of H2O. It is a oxidative ozonolysis. It is a oxidative ozonolysis. In place of H2O we can also take H2O2. Therefore the final product is carboxylic acid and carboxylic acid. It is a 1, 2, 3, 4, 5, 6. It is a adipic acid. It is a adipic acid and also called hexane dioic acid. Hexane dioic acid. Now this compound is heated. So here carboxylic acid, two carboxylic acids, and we are heating. It undergo dehydration. And form corresponding 7-membered anhydride. 7-membered cyclic anhydride. But we know that 7-membered cyclic anhydride is unstable. It immediately undergo decarboxylation, and in between these two CC bond formation takes place. So finally we get corresponding cyclopentanone and CO2. Cyclopentanone and CO2. The reactant has carboxylic acid and epoxide ring, and we are adding soda lime, NaOH, CaO, heat. So we know that the carboxylic acid undergo decarboxylation in the presence of soda lime. So we remove the CO2 and we will write down corresponding carbon ion. Now here we know that epoxide is there. So epoxide always formation and ring formation and ring opening both are possible, and here of course ring opening takes place and finally it gives corresponding product like this. After acidification it is converted into corresponding alcohol, allylic alcohol. Now this allylic alcohol treated with oxidizing agent MnO2. MnO2 specialty is it oxidizes only allylic and benzylic alcohols. It oxidizes only allylic and benzylic alcohols. Therefore allylic alcohol undergo oxidation and gives corresponding ketone. So it is a conjugated ketone. Now it is treated with hydrogen, base, tertiary beta oxide, and solvent, tertiary butanol, and heat. So whenever we are seeing the N2H4 and base, so this reaction is Wolff-Kishner reduction. This reaction is Wolff-Kishner reduction. Therefore, here the CO group will be reduced to corresponding CH2. So first manaki carbon ion form avuddi, after acidification corresponding alkene form avuddi. So it is a Wolff-Kishner reduction. The first one is soda lime decarboxylation, second one is allylic oxidation, and third one is Wolff-Kishner reduction. The reactant has carboxylic acid, 2 carboxylic acids, and for carboxylic acid we are adding H plus and methanol. So we know that when carboxylic acid treated with alcohol in the presence of H plus, ester formation takes place, and this reaction is known as Fischer esterification. Fischer esterification. And esterification indirectly proportional to steric factor. Indirectly proportional to steric factor. If steric factor is same, directly proportional to positive charge on CO carbon. Positive charge on the CO carbon. And directly proportional to electron density on alcohol. Electron density on alcohol. So here in the presence of H plus we can expect two kinds of reactions. One is like this and another one is like this. But the difference is this carboxylic acid group is less sterically crowded and this carboxylic acid group is more sterically crowded. That's why here I am taking less sterically crowded because indirectly proportional to steric factor. That's why the corresponding product is carboxylic ester at less sterically hindered carboxylic acid. So it is corresponding carboxylic ester. Now it is treated with H plus and ethanol. Again we are adding alcohol and we are having acid. So acid plus alcohol in the presence of H plus esterification. So in this case there is no other possibility, only one possibility is like this. In the presence of H plus esterification takes place. In acidic medium the esterification is known as Fischer esterification. Now it is treated with excess of dibal H, diisobutyl aluminum hydride. So this is a isobutyl, it is a isobutyl, diisobutyl aluminum hydride. So here temperature minus 78 degrees Celsius is granted. So here nucleophile attack, leaving group will leave. Nucleophile attack, leaving group will leave. Therefore corresponding product is here C double bond OH and the leaving group is ETO minus acidification granted ETOH. And here corresponding aldehyde and the leaving group is MEO minus acidification granted. So this is our final product. Here we got our aldehyde and aldehyde. The reactant has carboxylic acid, alkene and alkyl halide. It is treated with soda lime, NaOH, CaO, heat. It is a soda lime. So it undergo decarboxylation in the presence of soda lime and it forms corresponding intermediate carbon ion. And of course here we are having this kind of possibility because of resonance. We are having corresponding carbon ion. Now it is treated, it undergo elimination and finally it gives corresponding alkene. So conjugated ion is formed. Now it is treated with oxidative ozonolysis. It is a ozone structure. It undergo oxidative ozonolysis. We have to cleave the double bond and write down corresponding carboxylic acid, carboxylic acid, carboxylic acid and carboxylic acid. So it is simply an example of oxidative ozonolysis. Oxidative ozonolysis. Now, when you are heating this compound, it is a succinic acid. Succinic acid. So succinic acid undergo dehydration and form corresponding succinic anhydride. Succinic anhydride. And the oxalic acid on heating undergo decomposition. It gives corresponding CO2 water. So when we are heating oxalic acid, we get carbon monoxide, carbon dioxide, and water. The reactant has carboxylic acid. The carboxylic acid treated with SOCl2. It is called thionyl chloride. Thionyl chloride. In place of SOCl2, we can also use PCl5. We can also use PCl3. But among these three, SOCl2 is always best, because here SOCl2 will be converted into SO2, and which is a gas, so which drives the reaction for completion. So by adding any one of these reagents, simply here the OH group will be replaced by corresponding chlorine group. So finally we got carbonyl chloride. So this functional group is carbonyl chloride. Now it is treated with ammonia. When it is treated with ammonia, N lone pair attack on the carbon, leaving group will leave, because we know that ammonia is nucleophile and chlorine is a leaving group. Therefore, SN2 reaction takes place. SN2 reaction takes place and corresponding product is formed. C double bond O and H2 plus HCl. To remove this acid, we always need extra amount of ammonia. It converts into finally NH4Cl. So whenever we are seeing this kind of reaction, it need extra moles of ammonia to form to eliminate corresponding acid. Not only here, wherever we are using the base, if acid is producing, to remove the acid we need base. Now it is treated with dehydrating agents P2O5 or P4O10. These two are dehydrating agents. So here amide group is there. It undergo dehydration. So here H2 and here oxygen. It undergo dehydration and finally forms corresponding cyanide nitrile functional group. This is a cyanide and also called nitrile functional group plus H2. So here P2O5 and P4O10 acting as dehydrating agents. These two are dehydrating agents. Now structure of P2O5 and P4O10 is, so it is a structure of P4O10. It is a structure of P4O10 and which react with water and finally converts into H3PO4. The reactant is phthalic anhydride. The reactant name is phthalic anhydride. It is treated with nucleophile methanol. So here nucleophile is there and here leaving group is there. So nucleophile attack, leaving group will leave, and finally it converts into corresponding carboxylic ester and carboxylic acid. Now it is treated with PCl5. We know that carboxylic acid react with PCl5, the OH group replaced by Cl. the OH group replaced by Cl. So the corresponding product is COCl. COCl. So it has two functional group. One is carbonyl chloride, one is carboxylic ester. Now it is treated with methylamine. So here N lone pair can attack at this carbon, N lone pair can also attack at this carbon. So two possibilities are there, and we know the general rate of nucleophilic substitution reaction. RCOX more reactive than RCO, OCOR more reactive than aldehyde, more reactive than ketone, more reactive than carboxylic ester, more reactive than carboxylic amide. So this is the rate of nucleophilic attack. Therefore here ester won't react because RCOX is much more reactive. Therefore the corresponding product is and this compound on heating, N lone pair attack, leaving group will leave. So finally it gives corresponding product like this, and the leaving group is MEO minus. So this product is N-methyl phthalimide. N-methyl phthalimide. It is a final compound. The first reaction is nucleophilic substitution, second reaction also nucleophilic substitution, and third reaction when nucleophile attacking, COCl more reactive, so it gives corresponding product which on heating can form the cyclic compound. The reactant is phthalic anhydride. When phthalic anhydride treated with lithium aluminum hydride, it is a strong reducing agent, so we always use ether as a solvent. Therefore here, because of strong reducing nature, these two carbons undergo reduction, and finally we get corresponding primary alcohol CH2OH, primary alcohol CH2OH, because of complete reduction with lithium aluminum hydride. Now we are adding excess of potassium permanganate. It is a strong oxidizing agent. The primary alcohol or the benzylic carbon having hydrogen converted into corresponding carboxylic acid because of oxidation, and this compound name is phthalic acid. This compound name is phthalic acid. Now it is treated with methylamine and heated. We know that it is a acidic nature proton, it is acidic nature proton, it is basic nature nitrogen. Therefore initially acid base reaction takes place. Salt formation, initially acid base reaction. Now which on heating undergo dehydration and gives corresponding secondary amide, which on further heating undergo intramolecular SN2 type reaction, intramolecular nucleophilic substitution, and gives corresponding product like this. Leaving group is CH3NH2. So this product is known as N-methyl phthalimide. N-methyl phthalimide. The reactant has carboxylic acid and alkyl halide treated with soda lime, NaOH, CaO, heat, soda lime. So it undergo decarboxylation and form corresponding carbon ion. It undergo decarboxylation and form corresponding carbon ion. Now this undergo elimination. Finally it gives corresponding vinyl chloride derivative. Vinyl chloride type. It is a vinyl chloride, but here we are having extra carbon, that's why I am saying vinyl chloride type. When the chlorine connected to sp2 carbon, that is vinyl chloride type. Now it is treated with HCl. So here alkene function group is present. So alkene react with H plus and form stable C plus, and the stable C plus react with Cl minus and form corresponding geminal dichloride. Geminal dichloride. Now it is treated with aqueous OH minus, and which act as a nucleophile. Here we are having leaving group, and aqueous OH minus act as a nucleophile. Therefore here in place of Cl, nucleophile OH, in place of Cl, nucleophile OH. Now remove the water because it is a hydrate form and also geminal hydrate. So geminal hydrate is unstable. It loses water immediately and form corresponding aldehyde. So this is our final product. The reactant has multiple carboxylic acids, COOH, COOH. Now we are heating this compound, so it loses CO2. How it loses CO2? With respect to the COOH, alpha, beta, gamma. So remove the CO2 and write down corresponding answer. Alpha beta position double bond, beta gamma position single bond OH. And carboxylic acid, by losing CO2, it is a product. Now it undergo tautomerization and form corresponding carboxylic acid. Now this carboxylic acid, on further heated, loses water. So here you have to remove the water and write down corresponding anhydride. Now it is treated with PHNH2. Now it is heated with PHNH2. So here we know that nitrogen is a nucleophile. This reactant is known as aniline and also called benzenamine. Both are IUPAC, aniline or benzenamine. So nucleophile attack, ring opening takes place. So corresponding product is double bond O, NH, PH, C double bond O, OH. Which on further heating, intramolecular nucleophilic substitution takes place like this, and finally we will get corresponding product because of dehydration. Here proton, here OH minus because of dehydration. This product is known as N-phenyl phthalimide. It is a final product. The reactant has ketone functional group, alcohol functional group, carboxylic acid functional group. When it is treated with KMnO4, so this secondary alcohol undergo oxidation, and gives corresponding ketone and carboxylic acid. Now we are heating this compound with respect to the COOH. It is a alpha carbon. We can take either this one or this one. We can take any one of these, beta carbon or gamma atom. So it undergo decarboxylation and finally it gives corresponding alpha beta position double bond, beta gamma position OH, double bond O. Now it undergo tautomerization and finally it gives corresponding ketone. So this is a active methylene compound. Minus R, it is a active methylene compound. So this carbon is active methylene. Now it is treated with Br2. It is treated with Br2. So here we know that whenever we are adding electrophile, the active methylene has corresponding enol form, and this enol form is more than 1%. This enol form is more than 1%. That's why the enol form, whenever the enol form is more than 1%, there is no need of Lewis acid. Directly we can add electrophile. So here we are adding electrophile directly. So whenever we are adding electrophile, the tautomeric proton replaced by electrophile. It is simply electrophilic substitution. Electrophilic substitution. So this is our corresponding product. The reactant is phthalimide. It is a phthalimide and more acidic than water. So it reacts with Grignard reagent. R minus take the proton from the nitrogen and form corresponding conjugate base. It is a phthalimide ion. Now it reacts with benzyl bromide. So phthalimide is strong nucleophile. It prefers SN2 reaction. Therefore nucleophile attack, leaving group will leave, and finally we get corresponding N-alkyl phthalimide. It is simply N-benzyl phthalimide. N-benzyl phthalimide. Now it is treated with NaOH, H2O, heat. So this undergo hydrolysis. And gives corresponding phthalate ion, because we are doing the reaction in basic medium, and here it is a leaving group, pH CH2 NH2. It is a leaving group. After acidification, it will be converted into corresponding phthalic acid. Bromobenzene. It is an example of aryl halide. When it is treated with magnesium, of course we use a solvent ether. It forms Grignard reagent. Now it is treated with dry ice. Dry ice means CO2. Of course it is a linear, but for our convenience I am writing L shape. So here nucleophilic addition takes place. And it gives corresponding benzene carboxylate. benzene carboxylate. Now we are adding H3O plus. By addition of H3O plus, it will be neutralized and converted into corresponding carboxylic acid. Now the carboxylic acid treated with PHLi. When carboxylic acid treated with RLi, for example R-Li, first acid base reaction takes place and form corresponding RCOOLi and alkane. Now it reacts with another molecule of RLi. Nucleophilic addition takes place and form corresponding OLi, OLi, R dash. Now by the addition of H3O plus, O minus take the proton, O minus take the proton, it will be converted into hydrated form. If the carbon connected to two OH groups, that is called hydrate form. And also geminal diol. Geminal diol. Now it undergo dehydration. It gives corresponding ketone. So here simply pH minus will be attached after completion of this mechanism. Finally we get corresponding product ketone. So it is simply equal to benzene, C double bond O, benzene. And this compound is known as benzophenone. The reactant has two functional groups. One is alkene functional group, another one is halogen functional group. Of course, we have halogen, bromo and chloro, and it is a vinyl bromide. It is simply aliphatic. Now it is treated with KCN and polar aprotic solvent DMSO. When alkyl halide treated with KCN, we know that Cn minus is ambidentate nucleophile. Therefore, C can attack, N also can attack. Therefore, we get corresponding cyanide and isocyanide. And cyanide compound is major. Therefore, here we get corresponding product double bond Br, single bond Cn. Cyanide compound is major. Now it is treated with OH minus H2O heat. So we know that OH minus do not react with alkene. OH minus do not react with the bromine also, because double bond connected leaving group do not participate in the nucleophilic substitution reaction. So there is only one possibility, cyanide hydrolysis. Suppose it is a cyanide structure. When it undergo hydrolysis, we get corresponding product carboxylic acid and ammonia. If I consider acidification granted, carboxylic acid and ammonia. So in this case also cyanide undergo hydrolysis and we get corresponding carboxylic acid. Now the carboxylic acid product is reacted with CH3Li, that means RLi. So CH3 minus do not react with alkene and halogen, but it can react with acid. For example, carboxylic acid treated with R-Li, initially acid base reaction takes place and form corresponding RCOOLi and R-H. Now it react with R dash Li, R minus can attack, pi bond shifted, nucleophilic addition, corresponding product is OLI, OLI and R dash. Now by adding H plus, O minus take the proton and form corresponding hydrate form. It is a hydrate form. And also geminal diol. Geminal diol. Now it loses the water molecule and form corresponding ketone. It loses the water molecule and form corresponding ketone. So in this case also this acid will be converted into ketone. This acid will be converted into ketone. It is a final product. The reactant is carboxylic acid and halogen. Both functional groups are present. Alkyl halide and carboxylic acid. Now this reactant on heating, so this is a alpha carbon, it is a beta carbon, it is a gamma. So you can remove this CO2 and similarly it is a alpha carbon, it is a beta carbon, it is a gamma. Therefore there are two possibilities. One possibility is suppose below the plane CO2 decarboxylated, we get corresponding product like this. Suppose above the plane CO2 decarboxylated, we get corresponding product like this. Now it is treated with zinc and dilute HCl. Zinc and dilute HCl. So alkyl halide undergo reduction. Alkyl halide part undergo reduction. And finally we get corresponding carboxylic acid. Below the plane carboxylic acid is also equal to above the plane carboxylic acid. Because if we rotate about the sigma bond, we will get the same compound. So we know that when alkyl chloride or bromide or iodide, when treated with zinc and dilute HCl, the alkyl halide part undergo reduction. But alkyl fluorides do not undergo reduction. Now this carboxylic acid treated with Cl2 and PbR3. So PbR3 is Lewis acid and from Cl2 we get electrophile Cl+. We are adding electrophile in the presence of Lewis acid. So this is a alpha carbon. With respect to COOH, it is a alpha carbon and here one proton is present. So this proton is tautomeric proton. Tautomeric proton or enolizable proton. Enolizable proton. Therefore, in the presence of Lewis acid, electrophile Cl+ undergo electrophilic substitution. This reaction is known as HVZ reaction. Therefore, the corresponding product is carboxylic acid and alpha position Br. In place of H+, we should write Br. So it is an example of electrophilic substitution. Of course, Br can approach from the above the plane and below the plane, but here there is no stereochemistry. That's why we are writing only single compound. The reactant has carboxylic acid functional group and alkyl halide functional group. Now this compound on heating with respect to COOH, alpha, beta, gamma double bond, and with respect to this COOH, alpha, beta, gamma. So there are two possibilities. One possibility is, suppose above the plane COOH decarboxylated, it is a product, and below the plane COOH decarboxylated, it is a product. Now these two products are same, because about the sigma bond, if you rotate this molecule, so this COOH becomes below the plane, this carbon becomes above the plane after rotation, comes here, and this Br comes here but below the plane. So these two compounds are same, so you are getting only single compound. Another product treated with the magnesium or I minus acetone heat. So when you add magnesium, so initially what happens in the presence of magnesium, so initially carboxylic acid loses its proton because it is a metal, and after that Grignard reagent formation takes place. Now here minus and leaving group anti-elimination, and corresponding product will be formed like this. If I consider acidification grantedly, this is a product. Suppose if I add I minus acetone, so I minus do not remove the proton from H plus from carboxylic acid, and second possibility, I minus attack on the bromine, so Br2 eliminated like this, IBr plus Br minus, and the product is this one directly. సో మెగ్నీషియం యాడ్ చేసినప్పుడు యాసిడ్ బేస్ జరిగిద్ది, గ్రిగ్నాట్ ఫామ్ అవుద్ది, గ్రిగ్నాట్ ఫామ్ అయిన తర్వాత ఎలిమినేషన్ జరిగిద్ది, తర్వాత ఎసిడిఫికేషన్. అదే ఐ మైనస్ ఎసిటోన్ అయితే మనకి కార్బాక్సిలిక్ యాసిడ్ నుంచి ప్రోటాన్ని రిమూవ్ చేయదు. ఉన్న ఒకే ఒక పాసిబిలిటీ ఏంటంటే ఐ మైనస్ బీఆర్ మీద అటాక్ అవుతుంది, యాంటీ ఎలిమినేషన్ జరిగిద్ది, కరస్పాండింగ్ ఐబీఆర్ ప్లస్ బీఆర్ మైనస్ ఫామ్ అవుద్ది, అండ్ కరస్పాండింగ్ ఆల్కేన్ ఫామ్ అవుద్ది, అండ్ ఐబీఆర్ అండ్ బీఆర్ మైనస్ మళ్ళీ మనకి రియాక్ట్ అవుతాయి, and finally we get corresponding IBr plus Br minus ఫామ్ అవుద్ది, అండ్ IBr అనేది మళ్ళీ మనకి I మైనస్ రియాక్ట్ అవుతుంది, సో ఇట్ గివ్స్ కరస్పాండింగ్ I2 plus Br minus, I ప్లస్ అండ్ Br మైనస్, I ప్లస్ I మైనస్ I2 ఫామ్ అవుద్ది, Br మైనస్ బయటకు వచ్చేస్తుంది. సో ఫైనల్ మనకి ఇక్కడ I2 అనేది బయటకు వస్తుంది. The reactant has alkene functional group and carboxylic acid functional group. When it is heated, it undergo decarboxylation because with respect to COOH, alpha, beta, gamma. So beta, gamma unsaturated carboxylic acid, so undergo decarboxylation on simple heating. Therefore the product is, after removal of CO2, alpha beta double bond, beta gamma single bond CH. Now alkene is formed. Now this alkene treated with KMnO4 heat, When alkene treated with KMnO4 heat, alkene undergo oxidative cleavage reaction, and finally it gives corresponding carboxylic acid and formic acid. And formic acid undergo further oxidation, finally converts into CO2. Now the carboxylic acid treated with Cl2 and PbR3. Cl2 and PbR3. PbR3 is Lewis acid and Cl2 electrophile Cl+. So to the carboxylic acid we are adding electrophile Lewis acid. It is a HVZ reaction. In the HVZ reaction, if alpha proton is present, this alpha proton replaced by electrophile, and electrophile attached to the carbon from the above the plane as well as from the below the plane. So it is a alpha chloro acid. The reactant has alkene, carboxylic acid and carboxylic acid. It is heated. When it is heated, if you observe the reactant with respect to COOH, alpha, beta, gamma. So it is a beta gamma unsaturated carboxylic acid. So it undergo decarboxylation and it gives corresponding product like this: alpha beta double bond, beta gamma single bond, alpha beta double bond, beta gamma single bond, and COOH. Again, if you observe the reactant, it is alpha, beta, gamma. So again it undergo decarboxylation and finally it gives corresponding product: alpha beta double bond, beta gamma single bond. So this is our final product after decarboxylation. Now it is treated with HBr. When alkene treated with HBr, it undergo electrophilic addition. Alkene react with H plus and form stable C plus, and C plus react with Br minus, and finally we get corresponding isopropyl bromide. Now it is treated with magnesium. So it is an alkyl halide. When treated with magnesium, it forms Grignard reagent. Now the Grignard reagent treated with the CO2. React with the CO2. So nucleophilic addition takes place. Corresponding carboxylate ion. Now it takes the proton. Finally it converts into carboxylic acid. The reactant has alkyl halide functional group and three different halogens are there: chlorine, bromine, iodine. It is treated with excess of NaOH, and OH minus can act as base as well as nucleophile, but here there is no possibility of elimination because there is no beta proton. With respect to leaving group, it is alpha carbon, it is beta carbon, no elimination. So there is only one possibility, nucleophilic substitution. So nucleophilic substitution takes place repeatedly, and finally we get corresponding product like this. Now we know that if the carbon has two OH groups, it loses water immediately and converts into carboxylic acid. Now this carboxylic acid heated with soda lime. It undergo decarboxylation and corresponding product will be formed. So initially we should write carbon ion, after that acidification granted. Now this benzene treated with H2PD, so it is a catalytic hydrogenation. So no other functional group is present. That's why we have to take reduction for benzene. So benzene undergo reduction and finally gives corresponding cyclohexane. And hydrogenation always exothermic reaction. Heat of hydrogenation directly proportional to number of pi bonds, indirectly proportional to stability of isomer. The reactant is phthalic acid. It is a phthalic acid. When it is heated, undergo dehydration and form corresponding phthalic anhydride. So this product is phthalic anhydride. When it is treated with excess of PCl5, so here we have to break this bond. So it converts into COCl and leaving group COOH. And we know that again the carboxylic acid react with PCl5 and finally it form corresponding product like this. Now it is treated with methylamine. So N is a lone pair, N having lone pair nucleophile, and chlorine is a leaving group. So nucleophilic substitution takes place and it gives corresponding product like this. Now this N lone pair again react with carbon, loses leaving group, it undergo nucleophilic substitution, finally it converts into corresponding N-methyl phthalimide, It is a final product. The reactant is carboxylic acid and alcohol. It is treated in the presence of H2SO4. So it is a carboxylic acid and it is alcohol undergo esterification. So this is known as Fischer esterification. Fischer esterification and form corresponding lactone. Now it is treated with H2PD. So carboxylic ester and H2PD, no reaction, because we know that it is a catalytic hydrogenation. It do not reduce acid, ester, amide and epoxide. So these functional groups usually cannot be reduced in the catalytic hydrogenation. That's why further reaction not possible.